Hello everyone. In the series of 8051 microcontroller, today let us see interfacing of LCD. So before interfacing any module, we should study about pinout, description and the working. So the pin description of LCD, here I am taking 16 by 2 LCD. It's my LCD component. This is the 16 by 2 LCD which consists of 2 rows and 16 columns. On each row, you can display 16 characters. So LCD consists of, let us see the pinout of LCD. So pin number 1 and the pin number 16 both are used for ground. Pin number 2 and pin number 15 have to be connected to the VCC, and pin number 3 is for backlight contrast purpose, so that we have to connect like a 1 to 10 kilo ohm resistor. Ground line, and fourth one is the RS, that means register selection. So which consists of two registers which are called data register and command register. So from the microcontroller we are trying to send data as well as commands. When you are sending the data, at that time you should select RS equals to RS equals to 1. When you are sending commands to the controller, then send logic 0. Okay. So usually from the microcontroller we are trying to send data as well as commands. And the fifth one is the RW, which represents read or write. So usually we are performing always a write operation. So from the microcontroller we are trying to send some data as well as commands, so that better you connect to RW is always 0, means connected to the ground terminal. And sixth one is the enable line. When we are sending the data as well as commands we should enable LCD module. So how to enable LCD module? So by sending act to high pulse, after that with some time delay, then low pulse. So from the microcontroller by sending act to high pulse means logic 1 with some time delay, and after that by sending act to low pulse we can enable LCD module. So when you are sending the data, when you are sending the commands, both the times we should enable EN signal, enable line. So these three are the control signals for LCD module. What are the three control signals? RS, RW and enable. And after that, which consists of 8 data lines, pin number from 7 to 14. 8 data lines which are connected to the microcontroller in order to send data. This is the brief discussion about the LCD module. Alright, now let us start the coding part. Before writing the code, let us see hardware part. Let us see the hardware connections. As per that, always we are going through the coding part. See here, you can see RS line is there, RW enable. In the Proteus simulation, you cannot find remaining two signals, 15th and 16th line. So first one is the VSS, how to connect to the ground line, VDD power supply, and third one is the contrast. In the simulation purpose, you can neglect these three pin connections in a simulation, but when you take hardware, you must and should connect all the lines. So I'm ignoring first three lines, and we have three control lines: RS, RW, and enable. So RW is always 0. Why? Because we are performing only write operation. We are not trying to send any data. Okay, and port 3 is there. So port 3, I would like to connect to the D0 data lines, D1, D2. So that's about the connections. RW, it is always ground terminal, which is not programming. So this is the connections in the Proteus circuit. So from this, let us see the coding part. Right. So before writing the code, first of all, we should initialize the coding part. When you are writing the code, we should initialize LCD. So how do you initialize the LCD module? So by sending a group of commands, you can initialize LCD in a proper manner. So we have to send a few commands, commands like here 38 command, 38 command, which is used to which are representing you are sending the data or commands in the 8-bit format, 8-bit mode. Actually, you can send the data from microcontroller to LCD in two ways, 8-bit format as well as 4-bit format. So in this one, you are sending the data in a 8-bit format. And next command 06, it is representing increment the cursor position, and 0C display on, cursor off. Next command 80. So we have a 2 rows and 16 columns. First row, first column indicates 80th position, address 80. First row, second column indicates 81 position. So we are going to, if you address 80, then it indicates first row, first column, and 01 command, which is used to clear LCD module, which are the commands we have to send from microcontroller to LCD. Right? This is the required information before writing the coding part. Okay? Now let us see the coding part. So let's initialize. In our hardware section, RS is connected to port 2.0, enable line is connected to port 2.1, and D0 to D7 data lines are connected to port 3. RS equate connected to port 2.0. for 2.0. So it is not a case sensitive language, so that you can use anything, no problem. RW is not connected, it is actually ground terminal, and enable, which was connected to port 2.1, and I'm representing port 3. So we have a data lines, 8 data lines are there, which are connected to port 3. Now I'm keeping the label name as LCD, that is the installation part. uh, After that, let's start the LCD installation part. In that process, we have to send a group of commands. What is the first command? 38 number. So we should take 38 number into the A register. (38H). After that, send to the LCD module. So we have a 5 commands minimum. So I'm making some programs. When you are sending the command move a comma 38H, then a call command, a call command. Somewhere you have a command, it will come to command. So here we can send the content of A to the LCD. Here LCD is representing port number 3, which was connected to 8 data lines of LCD. So after sending every data or command, we should operate control lines RS, RW and enable. So RW already connected to ground terminal, which is stick a constant. Then you can operate two control lines RS as well as enable line. Now we are trying to send command. So when you are sending the command, RS should be 0. Why? Because we have a two registers, data register and command register. So now you are sending the commands. In order to do that, we should select command register, then RS should be 0. So we have a single bit instructions in the 8051. So to clear the data, we have a statement as CLR, clear RS, single bit instruction to clear, to write 0. Okay, clear RS, and RW is connected to ground terminal, so that no need to programming, and we have a enable line. So enable line is there. How to enable the signal? By sending active high pulse, time delay, then low pulse. So first one is high pulse. To write the high pulse, we have a statement as set B, set bit RS, enable, then delay. Again for delay, I'm taking one more subprogram. Actually, command is a subprogram. Within the subprogram, you are having one more subprogram, delay. Hash 100H. Okay, already we written the program for loop, how the instructions are executed. I can refer previous video for that. So that's it. This is the subprogram. In the subprogram, last statement is the return. Now return to previous program. This is the previous one. So you return active high pulse for the enable line. then time delay. After that, active low pulse. Clear, enable low pulse for enable. That's it. So now this is the last statement in the subprogram, so that you should write return statement. So don't get confused. Nothing is there. Installation part. Define ports to the variables or labels. After that, we are trying to initialize LCD. Initialization of LCD. So semicolon indicates comment section, right? So we have sent the 38 number. In the same fashion, you can transfer remaining commands. Move a comma hash. So hash. The second command 06. After that, equal command. Next command is the how you are sending the data command for the first command. In the same fashion, we can send remaining control values, remaining commands. What is next command? 0C. So in the same fashion, we can represent remaining commands also. 0C 80. And 01 H. That's it. That was the installation part. And next part is the send data from microcontroller. So first of all, whatever the data you want to send, define at the bottom of the code. So I want to display something like welcome welcome to robotic universe. On each row you can display only 16 characters. So origin, I would like to store my string from 1000 location onwards. Okay, after that write text1 db within the double quotes, which should mention our string comma 00, and the second string. So I'm taking the remaining one in the second line. Try to see that. Let me display one string. Welcome to robotics. Okay, so it is the text begin from 1000. So how you are sending the data from microcontroller to LCD means from the 1000 it is the memory location. From 1000 memory location onwards, our string was copied. So letter by letter, pick from the memory to microcontroller port, and after that we can send from microcontroller to LCD, right? So first you are getting W character from 1000 location onwards. You are sending like a char by character, character by character. First you are sending, you are picking W from 1000 location, and E copied copied onto the 1001 location, next letter from the 1002, next letter from 1003, 1004. Likewise, our string was stored, right? So we have a 8051 microcontroller. In that, one of the most usage register, DPTR. It is a 16-bit register. Move DPTR, comma hash 1000. Something happened to the system. 1000H. So from 1000 onwards, we have a data string. The starting address of string copied to data pointer. So with reference of data pointer, I am trying to pick up characters one by one. So to fetch the characters, the way of syntax is move c a comma at the rate of a plus dptr. So already data pointer representing 1000 location, and at the rate of a, at the rate symbol indicates the register consists of address, not the value. Okay, suppose if a equals to 10 number, that 10 number is adding with the data pointer. Okay, so suppose if a equals 10 and data pointer value 1000, both are added, then value becomes 1010. But our data starts from 1000 location. So in that case, a value should be 0. Then only you can get value from 1000 onwards. So before fetching the value, better you clear accumulator value. Now here accumulator value a equals to 0 and dptr equals to 1000. Both are added and value becomes again 1000. From 1000 onwards, you are fetching first character so that you will get W. Okay, so in the define value, define string, at the end you have a 00. It is outside of the double quotes. Whatever you mention within the double quotes, the data has been stored in the form of ASCII values. Okay, out of the double quotes, it is normal value like a hexadecimal value. Okay, at the last finally, in the fetching process, you will get 0. This 00 indicates end of your string. For the identification of string, at the end I am taking 0. So in the fetching process, finally you are getting 0. If it is 0, I don't want to display. If it is 0, in the fetching process, at one time you are getting 0. If it is 0, then don't display anything. Simply go to exit point. Somewhere you will be having exit point. Okay, in case if it is non-zero, if you get any other characters like a W, EL, welcome, robotics, any characters you are getting, then it has to be sent to the LCD module. So again for that I am taking one more subprogram as send. Okay, so here I am taking subprogram as send. Again, A has a W character. It is sending from accumulator to LCD. So after sending every data or every command, we should operate RS enable lines. So now you are sending the data. In order to do that, RS should be 1. So set bit RS. Why? Because you are sending logic, you are sending the data, so we have to select data register. In that case, RS should be 1. Then enable line should be high pulse. Then time delay, already we have a subprogram for the time delay, and active low pulse at enable signal. That's it. This is the last statement in the subprogram. So return to main program. This is the main program. Now we fetch first number, verify the condition. If it is 0, jump to exit point. Otherwise, send to LCD module. For the sending the data to the LCD, I have taken subprogram. So now successfully you sent or you displayed one character on the LCD module, and you have a remaining characters. So where is second character? Second character begin from 1001 location, but as of now data pointer value 1000. And also after displaying one character, better you should provide some time delay. Okay, after that increment data pointer to point out address of a second character, that is 1001. Okay, so in the same fashion we have to fetch all the characters. Okay, so short jump to Surya. Surya is the label. As a label you can mention anything. Okay, this is the target. Again, clear accumulator value. Now L value, accumulator value becomes 0. Okay, after that already data point incremented, so that it will point out 1001, and A value already 0. 0 plus 1001, again 1001. From 1000 onwards we are having second character. So definitely if it is a non-zero. If it is 0, it will jump to exit point. If not, a call send the second character to microcontroller. For that we have a code. Okay, so here I'm writing short jump exit point. By writing this statement on LCD module, only one time your character will be displayed. Okay, so this is the coding part. Now let's verify on microcontroller. This is the actual source of code. But when you are implementing LCD interfacing code on Arduino, it may take like 5 to 6 statements. So where in the Arduino section we are having many library files. But here ourselves we are initializing the code. So come to the key. After that, add your source file, save it. Already have copied, saved the content. lcd1.asm. Save the file and later add to source group. And after that, compile. So one error is there. Hmm. Let's check 90. Move r0 comma 90h. Yeah. Zero errors. After that, create X file. Come to output. Click on create X file. Suppose I'm giving name as LCD123. Okay. Now again compile. Now your X file was ready. Come to Proteus. Just upload your X file. LCD123.x. Welcome to robot. So actually we mentioned robotics, but On each row you can display only 16 characters. Okay, if you want to display the string on second row, we have to change the command. So before displaying the command, before displaying the command we have to address second row. So second row address D naught. Sorry, not D naught, it is C naught. Let's check out. Yes. So C naught is the second row first column. C1 second row second column. C2 second row third column. Just like that you can mention any row, first row or second row. For to display from the first row first column, what is the command? 80 number. Yeah, that's it. Thank you. If you have any queries, you can ask me in the comment section. Have a good day.